Hi, this is Catherine Rabick, HRAB as in boy, IK. This is the Csc478 final code walkthrough and review. I did want to just start out with a little introduction into what I'm doing. So essentially what I'm doing is a local restaurant allowed me to use their transaction data from January 2016 through May 2018 to predict future sales using past data. So first what I did was I kind of reviewed the data that was given to me, and you can see it's a little bit messy. So there was some definite pre-processing that happened here. I ended up keeping all prices, all item names, dates, which are up here, times. Some of the stuff I actually left covered up here. There's transaction data. There's actually credit card numbers in here, as well as customer names. So a lot of that was wiped. Just for these purposes, there wasn't that much that I needed as far as, keeping things lumped together as transactions. Although this data set actually could be kind of cool for like a market basket analysis, if that's the way I was planning on going, that would have been actually pretty cool. So once all of that was kind of wiped out, there was some aggregation that happened just to kind of get everything all lumped together. Also, a couple of things that I did add, I did some feature engineering. So what I'd like to show you here is after discussions with like the area manager and some of the employees that work there, I was just kind of trying to see what other types of features I might be able to add in, what might be able to give me a little bit more accurate of a prediction. And they did say that their business seems to be extremely dependent on weather. So not only do sales rise and fall like throughout seasons, so you can see I added seasons there, but also if the temperature is really low, or especially precipitation, if it's raining or snowing, their sales for the day dip way down. So I thought it might be kind of interesting to see what happens if I added in some of those features. So what I did was I went to the NOAA website and I pulled climate data from the time period in question and just kind of appended that on there. And that wasn't anything I did in Python. I actually, since the data came over as a CSV, it was really easy to just kind of put that in with VLOOKUP. So that's all I did for that. So this is just me holding some of these names for the later use. That I use it later on to kind of create some of my spreadsheets that I work off of later. So one thing I did want to see is I wanted to see, how much sales really do differ based on season. I wanted to see if seasonality really had as much of an effect as they were saying that it had, and it does look like there's definitely some trends here. So I took some just sample items and I ran probably, I want to say like 20. But there, at the time that I started, there's actually over 100 items. I think there was 108 before it was cut down. And I'll explain how I cut them down in a minute here. But so here's some of the items that I was looking at, and you can see that particularly hot dogs sell really well in spring. Then we have these things they're called California burgers that definitely rise in spring and summer, kind of with the whole trend of the year. Their overall sales are just better in spring and summer. But then these two down here, which are lemonade and bottled water, you can see as it gets hotter, those are kind of directly correlated with the season, with summer, maybe summer break, high school students, stuff like that. So I figured that was a good indicator for sales. So I left that in. And here's a couple more just to show you that, it really depends on the item. Not everything was perfectly correlated with just spring and summer. Some of it, you could see the All-American single, it actually goes a little bit down in summer for the year in question. And, there's definitely some different trends depending on item. So overall, it's obviously going to rise in summer, but it's not completely, all following that pattern. Okay, so what was I doing here? Oh, okay. Okay, so one other thing that I wanted to check is I wanted to look at weather. So I wanted to see if weather actually was an appropriate indicator of, whether or not they were going to have good sales that day. And the relationship between temperature and sales, I mean, overall for, like an aggregate of like seasons, again, warmer months, more sales. That's going to be pretty standard. So that doesn't really necessarily add that much value. But interestingly, precipitation related, I thought at least. So this is actually just a really small sample. I tried to narrow it down as best as I could because I have years worth of data here. So this is kind of me trying to blow it up. But what it looks like here is it looks like when there's more precipitation, sales go down. But when there's no precipitation, it's kind of independent of precipitation. So no, like it's anything can happen on a day when it's not raining, but if it is raining or snowing, sales definitely go down. And I thought that was pretty interesting, so I left that in as well just to see what would happen. So what I chose, since this is kind of like a time-based sequential linear data set, is I just went with linear regression. I did email you a couple times about, I was going to try time series originally. I didn't hear back, and I was kind of afraid to do time series since that wasn't something that we did in class. So I figured I'd stick with the models and tools that we learned in class. So this is just me setting up my data, splitting it into train and test. I did end up doing a min-max scaler. So I scaled all the numeric values, like all those weather values and stuff like that, since they're all on different scales. I actually scaled them all just to the same scale between 0 and 1 to kind of match the scale of everything else because I didn't want anything being inappropriately overvalued. That I didn't want it to carry extra weight just because it was a different value type. So when I did the linear regression, you can kind of see that the error here, it's the root mean square error is 2.89. And I did want to back up because I think I forgot to say that I did when I was feature engineering, when I was cleaning the data, I was made aware that I think it was like 10 or 20 of the items were only sold within the first week and then like immediately discontinued. So I did delete those. I did want to say that. I said I was going to come back to that and I didn't. So I just wanted to let you know that real quick. All right. So yeah, so our root mean squared error is 2.8, and it really depends on the data, kind of what that means. For us, the difference is, I guess, in the units of our prediction variable, so 2.8 items, which really isn't that horrible. So what I wanted to do was kind of look at how how the predictions stood up against the actual values, and it's it's a little wonky. It's not too bad. It's actually pretty close considering. And now I did want to say this is another one of those ones where in the document I blew it up a little bit. I'm only looking at a little subsection because I had so much data that it just got out of control to try and look at, especially when it was blown out further. You couldn't see any difference. It looked like the blue line and the green line were the same thing. So I just wanted to show you there is some very, very slight variation here. So you can see here, some of them predict really well. Whole wheat buns, almost the same thing. Blue cheese, we're getting pretty close. Everything's within a pretty good range. I did want to look at ones that were kind of a little bit problematic. So you can see, like, on certain occasions, there's ones that are way off. There's, the original, they actually sold 7 and we're predicting 22. And part of that, in my opinion, is because all of the employees have different methods of ringing things in. So there's not a standard operating procedure. So like there's multiple different examples, like one employee will, every single time ring in that they use a pretzel bun, another employee will always let it default to brioche bun and will not make the, the required change to pretzel bun, just because it's a little faster to let it default to brioche. So particularly around buns and some of the cheeseburgers that can be rung in a couple different ways, it looked like it wasn't. I'm not sure if it's because, there's so many different employees entering things different ways, or maybe like one employee was working, for a couple weeks in a row and they were diligently ringing in pretzel buns the right way, and then all of a sudden they stopped working, or, it's really kind of the error centered around buns and a couple of the different cheeseburgers that can be rung in different ways. So I'm wondering if, the fact that they don't have a standard operating procedure affected the data at all. But either way, we're working with what we got, so it should be able to at least predict relatively well. I did do a couple regression operations here. I did L1 and L2. I just kind of wanted to see what would happen. And I also did elastic net, and we didn't really get to see too much of an improvement. You can see Ridge did improve it just ever so slightly, but really not, that great of an improvement. So, adding that extra penalty for, into the model really didn't seem to help in our cases. So we're looking again at kind of what happens after we do the regression. You can see, it's really close, but there's still some things, especially on items that, they're selling a lot of, we're going to be off a little bit. So where'd it go? Uh-oh. Okay, so this is kind of just plotting, actual versed predicted. So that is our, our linear regression line. And you can see a lot of the items that, they really are centered on like 0 to 10, 15 items a week sold. And then the more items that are sold, some of these other ones, it's predicting not as well. So, I mean, we kind of saw that in our data before. So because so much of it is concentrated in this lower range, as it goes up, it gets a little worse at predicting. So the only other thing I really wanted to show here, because everything else is in the report, I can show you. I did actually do one weird thing, and this isn't something that I'm submitting like as part of my final model or anything, but I wanted to see what would happen if I did everything categorical. So instead of, having these like ranges where it's, 7 brioche buns and like 85 whole wheat buns and all these different things, I wanted to put it within ranges. So I created these artificial ranges, less than $1 for price. I think it's $2 to $5, stuff like that, rather than individual temperatures, which are like, 35.5, where we just have cold, warm, and hot, or no precipitation and precipitation. So not even, taking into account like rain or snow, I don't think. So I wanted to see what would happen if I really, really generalized it and actually kind of took some of the precision out. So to do that, I just kind of, I know this video has been going for a really long time, so I'm going to kind of rush through this since this isn't part of my final submission anyway. But I tried, K-Neighbors classifier. I tried the decision tree. I tried multiple splits, multiple numbers of neighbors, and my accuracy was not great, especially with naive Bayes. It really went down. So I think taking out the precision kind of really muddied it and kind of took away from some of the linear trends that we had been seeing. I think maybe, especially since I made my ranges so broad, it just like really didn't work for me. But I did want to mention that there were, tons of different things that I had tried, and this what I'm submitting here is my pretty much my best model. So I believe that is it, and thank you so much, and I hope you have a wonderful holiday break. Thank you.